What if I told you there's a robot with 100 brains, not one big central computer, but tiny, fast-thinking minds spread across its body? Each finger, joint, and patch of skin can sense, decide, and act in real time. This isn't science fiction. It's Pi 0.5, the newest breakthrough in robotics. A machine that doesn't just follow orders, it thinks for itself, and does it instantly. From cleaning up your kitchen to folding laundry while dodging a human elbow, this AI doesn't just react. It adapts, learns, and keeps moving. No Wi-Fi required. Welcome to the future of robotics. This is the AI robot with 100 brains that thinks and acts instantly. Imagine a robot where every part of its body has its own brain. That's exactly what Pi 0.5 introduces, a radical shift from traditional robotics. Instead of one central processor controlling everything, Pi 0.5 uses a network of tiny neural modules called Pi nodes distributed all over its body. Each of these nodes is like a mini brain. There's one in the fingertip, one in the elbow, even soft silicone patches have one. And each node comes with its own sensors, micro neural network, and actuators. That means every movement, every adjustment, every reflex happens locally and instantly right where it's needed. No more waiting for instructions from a central server. These nodes operate independently, making real-time decisions based on what they feel or sense. After every tiny movement, the node checks. Did that improve grip? Did that reduce tension? And if not, it immediately adjusts, on the fly. The result? Robots that are incredibly responsive. In one test, a soft robotic gripper using Pi nodes improved its grip accuracy by 30% and used 25% less power. No lag, no signal delays, just pure reflex. And because the intelligence is baked into the hardware, it even works on ultra-low power chips like an ESP32. You could literally run one of these nodes off a coin cell battery. This isn't just faster, it's smarter. It means robots can adapt to real-world chaos, things like slippery dishes, shifting laundry, or surprise bumps without calling home for help. This is edge intelligence in action, reflexes redefined. And it's just the beginning. If the reflex nodes are the robot's muscles and nerves, then the upper-level Pi 0.5 brain is its mind, its intelligence, its reasoning, and its ability to make sense of the world. This upper brain is something called a Vision Language Action Model, or VLA. Think of it as a fusion of computer vision, natural language understanding, and motor planning, an all-in-one AI powerhouse designed to interpret your instructions and decide what to do, even in a brand new environment. Most robots struggle with generalization. Sure, they can perform a task, but only on the exact table, with the exact objects in the exact conditions they were trained on. Change the lighting, move the chair, or replace a fork with a spoon, and they freeze. That's where Pi 0.5 is different. The team behind Pi 0.5 tackled this limitation head-on by feeding it a monster dataset unlike anything in robotics. They didn't just train it in one lab or one house, they captured over 400 hours of real robot footage in real homes, doing real tasks. Robots bumping into chairs, figuring out how to grab weirdly shaped pans, scooping up toys, wiping tables with uneven pressure. Pi 0.5 saw it all. But they didn't stop there. They added static clips of robots in dozens of different environments. They introduced cross-embodiment learning, where simpler robotic arms without wheels contributed to the dataset. They threw in internet-scale image caption pairs, object detection challenges, visual question answering, and even verbal instruction sessions, where humans coach the robot through chores, step by step, using natural language. The result is a Frankenstein-like curriculum that covers everything from what is a pillow to how hard should I grip a ceramic plate. This broad, diverse training made Pi 0.5 incredibly flexible, and the numbers speak for themselves. In homes that looked similar to the training data, Pi 0.5 had an 86% success rate in understanding language commands and an 83% task completion rate, even for precise subtasks like putting every dish into the sink one by one. But the real shock came when they pushed it further. They ran an out-of-distribution test, a completely new home with different lighting, unfamiliar objects, and zero overlap with training footage. Pi 0.5 still crushed it with a 94% success rate. That's almost as good as if it had trained in that house. And when they removed key training data, like the internet photos or the multi-environment robot footage, performance plummeted, proving that diversity in training data isn't just helpful, it's essential. It's the oxygen that powers this brain. They even scaled the model across more than 100 different homes and found that performance improved almost linearly with diversity. Eventually, the model got so good it nearly matched a cheating baseline, a robot that had actually seen the test home before. That's the power of massive, varied, grounded data. And here's where it gets even more fascinating, or reliant. When Pi 0.5 is live, it doesn't just execute commands blindly, it actually thinks. Every second it goes through a chain of thought process, just like how a human might. First, it generates a high-level instruction, like pick up the pillow. Then it converts that thought into a stream of 50 precise joint movements executed in real time. Cameras update, sensors recalibrate, the whole system loops back for the next decision. This means the robot is constantly adjusting and replanning on the fly, combining language understanding, spatial awareness, and motor skills into a single smooth process. And the beauty of it? The upper brain doesn't have to micromanage everything. Because the lower level reflexes are so fast and reliable, the high level brain can afford to be a little slower, a bit more thoughtful. It focuses on the big picture, what needs to happen next, while the nodes in the fingers make sure the grip is firm and nothing slips. It's almost like how your brain delegates tasks. Your spinal cord handles balance while your conscious mind plans your next move. Pi 0.5 works the same way. So while older robots had to choose between speed and intelligence, Pi 0.5 has both, thanks to this two-layered brain system. It understands your words, it sees your home, it plans like a human, and thanks to its reflex-powered body, it executes with precision, on the spot, in the real world. This isn't just a robot with a brain, it's a robot with a mind of its own. So far, we've seen how Pi 0.5 is packed with tiny brains across its body handling reflexes, and we've explored the powerful upper brain that interprets language, vision, and complex tasks. But here's the magic, the way these two layers work together as one unified mind. This is where Pi 0.5 truly lives up to the idea of 100 brains that think and act instantly. Let's break it down. Every second, the upper brain, the vision language action model, generates a high-level command, something like, pick up the spoon by the handle. But instead of controlling every motor manually, it passes the baton to the local node brains, those reflex-driven Pi nodes spread throughout the robot's body. The nodes in the fingertips immediately begin adjusting grip, feeling for slip or resistance. The arm joints anticipate motion, checking for tension. If something changes, say the spoon starts to slide or someone bumps the robot's arm, these microbrains don't wait for help. They react on their own, instantly recalculating force and posture within milliseconds. This division of labor is what makes Pi 0.5 feel intelligent, not just in theory, but in practice. The upper layer is like a calm, strategic thinker. The lower layer is a team of elite reflex agents executing every move with precision. One thinks, the others act. Together, they adapt in real time. It's the difference between a remote-controlled puppet and a true autonomous system, and the technology driving this collaboration is no less impressive. Instead of using slow, step-by-step diffusion methods to plan motion, Pi 0.5 uses flow matching, an advanced technique that can produce a smooth, full-body movement trajectory in a single forward pass. No delay, no hesitation, just decision, motion, micro-adjustment over and over every second. The entire loop is designed to match human motor behavior. The robot creates 1-second action chunks, brief windows where it carries out its current plan while continuously re-evaluating its surroundings. It's short enough to stay agile, but long enough to complete complex gestures like lifting, turning, or wiping. And the best part, it all happens without relying on a Wi-Fi connection or cloud computing. Because the intelligence is distributed across the body, each node only runs what it needs. The result? Lower latency, lower power consumption, and real-time responsiveness even in unpredictable environments. In testing, Pi 0.5 was placed in actual strangers' apartments. No pre-scans, no markers, no perfect setups. The robot made beds, wiped spills, scooped toys, and even folded laundry. When interrupted mid-task, say an arm gets nudged, it didn't glitch or freeze. It recomputed and kept going. And it could handle both specific and vague commands. Say, pick up the round brush. It targets the exact object, or say, clean the bedroom, and it breaks that down into sub-goals like organizing items, wiping surfaces, and moving clutter, all autonomously. This level of responsiveness is something we've never seen before at this scale. Other robots rely on either brute force compute or rigid pre-programming. Pi 0.5 is different. It's modular, intelligent, and instantly reactive, exactly what the future of robotics looks like. So, when we talk about a robot with 100 brains, it's not just a metaphor, it's a new architecture of intelligence, reflexes in the body, reasoning in the mind, and a seamless flow between them. This is the foundation for machines that don't just perform, they understand, react, and evolve. Pi 0.5 isn't one brain doing 1,000 things, it's 100 minds working as one. So what does this all mean for us? It means the age of clunky, slow, overly scripted robots is coming to an end. Pi 0.5 isn't just a step forward, it's a leap into a world where machines can think fast, act smarter, and actually live among us in the chaos of everyday life. This is no longer about robots following commands, it's about robots that understand, adapt, and improve on their own. So next time someone says AI can't do real-world tasks, just show them Pi 0.5. Because the future isn't a single superbrain in a server rack, it's 100 tiny minds working together in perfect harmony. Thanks for watching. If you found this as mind-blowing as we did, hit that like button, subscribe for more deep dives into the world of AI and robotics, and let us know in the comments, what would you do with a robot like this in your home? This is the future, and it thinks faster than you do.